Here is problem number 35 on page 171. I'll read the problem. It says, you pull your 18-kilogram suitcase at constant speed on a horizontal floor by exerting a 43 Newton force on the handle, which makes an angle of theta with the horizontal. The force of friction on the suitcase is 27 newtons. A, what angle does the handle make with the horizontal? B, what is the normal force on the suitcase? C, what is the coefficient of friction? So I've set it up as shown here. Here's the suitcase, here's the floor. You're pulling on it with a 43 Newton force. It's inclined up at an angle of theta. We somehow know what the friction force is. It's 27 newtons. And we know the mass of the suitcase is 18 kilograms. So knowing all that, what is this angle? What is the normal force, that is the floor pushing up on the suitcase, and what's the coefficient of kinetic friction? It is kinetic friction. We have a velocity and it's constant. So let's follow the procedure for this. We want angles, but to get the angles we need forces and all that sort of thing. So here's our free body diagram of the suitcase. And we've got mg pulling like this. We've got the force of friction is 27 newtons. Got a normal force. Now I'm deliberately making the normal force smaller than the weight. Why is that? Because we're pulling up with an applied force like this, and that applied force is going to have an upward force, and if you add them together, they'll be equal to the weight. And I think that's it. Let's make this our x and y direction. So this is step 3 of the procedure. And, oh, why did I do that? Because it just gets in the way when it's over there. So we'll say, okay, this is x, and this is y. And so here's FA, needs to be broken up into its components. And so here's FA cosine theta, and here's FA sine theta. Now we know that FA is 43 newtons, but we don't know what its angle is, so that's really one of our unknowns. So let's go on to step 4. If I sum the forces in the, well, let's do the x direction first, equals MA in the x direction. And look at the force. Oh, there's only 2 forces in the x direction. That is FA cosine theta minus the force of friction equals, and they tell us that the acceleration is 0. So that's 0 right there. And then I can look in the y direction. And I look in the y direction, and I've got FA sine theta plus the normal force minus the weight equals, equals 0. Now, does everybody see how I constructed these 2 equations from the free body diagram? Everybody agree on the free body diagram? Now you've got everything you need pretty much to solve this, but you do have to think. You have to look at the picture, and you have to think. Well, here's the thing. I know what the force of friction is, and I know what FA is. So let's do part A. But I don't know what theta is. But I can solve. So I can solve for it. There's only one unknown in this equation. Yay. So I'll just rewrite the equation. FA cosine theta minus the force of friction equals 0. So therefore, bring this over there and divide. So cosine theta is equal to the force of friction divided by the applied force. And now I can solve for theta, you see. So theta will be equal to the inverse cosine of the force of friction over the normal force. I'll go ahead and plug in my values now. The force of friction, it was given to be 27 newtons, and the applied force was given to be 43 newtons. And so theta will be equal to, get my handy dandy calculator out here, so we'll go second cosine of 27 divided by 43, close parentheses, I am in degrees, and that's equal to 51.1 degrees. So this is really step 5 of the procedure, right? You set up your equations like this, and now you just solve for the unknown with the equations that you derived from the free body diagram. Now for part B, I'm trying to find the normal force, and that's all in the y direction here. So I can just now I know this now. So there's only one unknown here, and that's the normal force. So we'll solve for it. So the normal force is going to be equal to the weight. So add that to the other side, and subtract the y component of your applied force. So the normal force will be equal to 18 kilograms times 9.8 newtons of force for every kilogram of mass. That's the gravitational field, right? Minus the applied force was given to be 43 newtons times the sine of 51.1 degrees. So let's see, 18 times 9.8 equals 176.4 newtons plus 43 times the sine of 51.1. And when you do all that, I'm getting, that doesn't make sense. So what's 43 times the sine, 51.1, that's 33.46, or 4.5. So 176.4 minus 33.5 equals 14.29, or 143 newtons. Yeah, I don't know what I did wrong. First time I did it, it gave me some crazy big number. All right, and then for part C, well, we're looking for mu, and we know that the force of friction is equal to mu times the normal force. So mu will equal the force of friction divided by the normal force. You can use this as a basic equation if you want. And so the force of friction was given to be 27 newtons. My normal force is 143 newtons. So mu turns out to be 0.188, or 0.19. I'll just round it off to 0.19. Let's check it with the book. Yeah, 51 degrees, 143 newtons, and 0.1. Yeah, that's what the book got. So let me zoom all the way out here, and you can take a look at the whole problem. That is page 171, number 35. Any questions? And notice how on this problem I just follow that 5-step procedure. I mean, you have to think. You have to follow. You have to be able to do this correctly. That's where the physics is looking at the situation and figuring out where all the forces are and what direction they're in, and then using Newton's second law in the x direction and the y direction to come up with equations. These equations are different for every problem. It's all based on what you get on your free body diagram. And then after that, it's just algebra. If you've written these equations properly, it's just algebra. All right. That is all.